YouTube, welcome back. Today we have this problem called intersection of two arrays. Given two integer arrays, nums1 and nums2, return an array of their intersection. Each element in the result must appear as many times as it shows in both arrays, and you may return the results in any order. No problem with the order. For the example, we have 2 2 and 2 2 here, so basically we have the number 2 is shown 2 times here and the number 2 is shown 2 times here, so we turn 2 2. For this one we have 4 9 5 and we have 4 9 and 4 and 9. It's also displayed here, the 4 and 4 and 9 and 9, so we return it. So how can we solve this problem? Let's just go to the sketch. Let's put this one. Okay, so there's two ways to solve this problem. We can loop through each one of them, go through each one, and from each one we just can compare it to each element in the other array. Okay, and this one it could work. Just a minute. This one it could work, but it will have a time complexity of O of n squared. No, it's not O of n squared. Sorry, it will be O of n multiplied by m, whereas n is the length of this array and m is length of this array. Other way that we can solve it is to create a hash table. Okay, and inside this hash table we store the values of nums1 and we compare it to values of nums of n2, and we return the common things, and the time complexity will be n plus the time complexity will be O of n plus m. So let's try to see how we can do it. So first of all, I will do map. Okay, I will say const map equals new map. Okay, and I will say if let I'll say I want to loop through the longer array first. Let a bigger array, let's say bigger. It will be if nums1 dot length bigger than nums2 dot length. I'll put nums1, otherwise I'll put nums2 but not length. Yeah, because I want to loop through the bigger array and store it in the map, so we make sure that there is no missing. And I will say something that I will continue, and I will store the bigger in the map. So I'll say it for let n of bigger, for example, and I will say map dot set n. Okay, n yeah, and I will just edit by one because it's appeared one. However, let's see that is if this number is already there in the array. I want to know how much actually this number is in this array. So what I should do is that like increase it by one. I don't wanna just each time I'll say it by one. If it's this in this number in the table, I want to increase it by one. So what I'm going to do, I will do plus, and this one is saying that if this n is in the table, get this value of it, if otherwise just return 0. So I will say 0 or the value of this one. So map dot get in. Okay, and I will continue. I will have let k equal 0, and I will tell you why I'm using this k, and I will loop again through nums2. Let, wait a minute, I just want to have smaller, and because I have bigger right now, smaller, this will be nums2 and nums1, and I will say let's say make a for loop. I will say let n of smaller, okay, and I will say let count let count equals map the get. First of all, I'm getting the count, and the count that I get I wanna get the count of the n, map dot get in, and if n doesn't exists in the table, I put 0, and I'm saying that if this count is bigger than 0, that means this number exists in these two arrays. I will say nums let's create another one, let array, and this one will be empty. Let's say let result result equals an empty array, and I will return this result. I don't know how I forgot this result. Return result, and I'll say result of key will equals n, and I will increase k plus plus, and I will say map dot set n, which the number is be a count -1. We take 1 from it, and I guess that's it. Let's submit. Okay, so let's talk about what we have done. I guess when we continue the key, you understand the key, that it's just we update the results by the key, and after that we increment the key, and until we finish the full array. So first of all, we have two nums. Okay, we have bigger and small. Okay, and we start with the bigger one, and I guess we don't have to make bigger and smaller, but because of that, because you already have all of the elements already, because we are looking for the common, so you don't have to make bigger or smaller. But this is make the code looks like more reliable, I guess. So we have bigger and smaller end results. So first of all, I save all of the values of their frequency and the elements in bigger. Of bigger, I save it in a hash table. Okay, and after that I loop through smaller. Okay, and I say that if this n exists in the table already, that means this n, or this number, exists in nums1 and nums2. And if this is the case, what we are doing to do is that we take the we put this number into k. Okay, and we put we increase k, because let's put the so we make sure that we're trying to adding and not to try to push. Basically, you can, instead of making results of k, you can just make results that push in. You don't have to have k at all. You could just have results that push n, and that's it. You don't have to have key at all. So we push this number to the result, and after that we set the count, so to make sure that the count is after the 0, so we will not keep adding this number over and over and over and over again. And I guess that's it. That's it for today's video, and I will tell you why. Yeah, before we're doing the count minus 0, if you look at this one, we have 2 and 2 and 2 and 2. Okay, so this 2 is have 2 times. So basically, this 2 will equals to 2 because it's this like in the table we have 2 and equals to 2. That means this 2 number, it's appeared 2 times. And first, when you find this 2, the first one you take 1, and after that you continue to loop, and you find the second 2. You say this second 2 equal the count is still equals 1, or it's bigger than 0. Yes, so you can add the second 2. So because we're doing this count, if we didn't do this count at all, we will have 4 9 and 4 9, but this is not right, because we only have 1 4 9 here, and we have 2 4 9s here. So we want to have the common between them, and the common is 4 9 and 4 9. So because of that, we just taking 1 from the count to make sure that we don't have this problem at all, and we make sure that we are retaining the result of must appear as many times as it's shown in pos array, and we just and by decreasing the counts, we make sure that we satisfying these specific requirements. So that's it for this video. I hope my solution was quite good, and see you in future problems.